What you know about black holes is probably wrong. The theory of the most genius scientist of the century, Albert Einstein, has been proved wrong. Because a genius mathematician from New Zealand, Dr. Roy Kerr, who himself mathematically described black holes in 1963, has proved that the singularity of a black hole, that is, the point where all its mass and gravity are centered, does not exist in reality. The concept that Einstein used to believe in, do you understand now? Well, the singularity of a black hole is the actual black hole. A vent horizon is created through its intense gravity, and black holes suck things in. So, when the singularity does not exist, is the existence of black holes a lie? Hypothetically, if the existence of black holes is a lie, then what was the image of a black hole published by NASA in 2019? Can black holes exist with their event horizon without singularity, that is, without any source of gravity? Or is there something else in them that is giving birth to their intense gravity instead of singularity? And if yes, then what is hidden in black holes? Well, to find out, we have to first go to the root of this whole puzzle, which is Einstein's general theory of relativity, from where black holes, singularity, wormholes, dark matter, all these concepts originated. So, I would highly suggest that you do not skip this part at any cost, because those who think that they have understood the relation between gravity and space-time fabric well, understand that 95% of people are wrong. So see, the way we have visualized gravity so far, like there is a space-time in which if an object is placed, it gets curved due to the weight of that object. Scene 3, the flaw in visualization. This visualization is completely wrong, because if you look at it carefully, you will understand that we are using gravity to explain gravity, and that is why this model is not an accurate representation of space-time curvature. Actually, gravity comes due to curvature, and curvature is not created due to gravity. And let me explain this. Imagine that there is a bucket filled with water and you put a ball inside it. Now, what will happen with this? Obviously, the more space the ball takes inside the water it will push aside. Archimedes' principle, right? The same thing happens with space-time. If I put this ball in space-time, the more space it takes, the more space-time it will push aside. And this will create a curvature in the space-time next to it. And scientists say that this curvature creates the gravity of the object. Because around the object that creates that massive gravity, other objects start traveling in curved paths. And all curved paths eventually attract towards the center of that massive object. Now, how do they attract? Well, according to general theory of relativity, every object, you, me, a ball, all are in a state of free fall. That is, a straight line motion. But when a massive object curves space-time, we come from straight free fall to curved free fall. And because of the curviness of the path, the direction of our fall goes towards the center of mass, which creates a feel-like attraction. And this is what we call gravity. Now we can also understand this same concept with another easy interpretation, which is the river model of general relativity. Maybe this analogy is easy for you, or you can try the previous one. So the river model of general relativity says that when a curvature is created in our space-time, then things don't fall in that hole because those things get stuck in that hole. Instead, they fall in that hole because the space-time below it starts falling with those objects. Basically, whenever a curvature is created in space-time, then space-time starts behaving like a waterfall, which starts flowing things floating on it and makes it fall in the curvature. Now you must also know this, it's pretty much common sense. We start moving towards the edge of any waterfall, and similarly, the flow of water becomes faster. So in this case, If you are in a boat and you have to save yourself from falling in the waterfall, then the closer you get to the edge, you have to accelerate the boat in the opposite direction as fast as possible. If you somehow succeed in this, then technically you will be moving in the backward direction, but still, you will be seen from a paused third-person perspective. Now, in the context of a black hole, this is exactly the point where a small mistake and the game is over. Because usually at the edge of the curvature of a black hole, its event horizon, the speed of the flow of space-time reaches up to light speed. Because of this, nothing in the universe can go in the opposite direction, except just light. So now you understand why everything falls in a black hole. Now you know why I told you all this. Well, see, the event horizon of a black hole, its edge, makes everything make sense here. But you also know that a black hole is called a black hole because even light cannot escape from it. Now this is only possible when we assume that beyond the event horizon, the flow of space-time becomes faster than light speed, and not just space-time but of information transfer. Because the object or even light ray that goes inside the black hole cannot come out of light speed, and this is the biggest paradox. Can anything in this universe travel faster than the speed of light? Obviously not, right? And this is the very essence of general theory of relativity. So all in all, the assumption on which GTR is based, the same assumption breaks inside the black hole. And in this context, if we apply general theory of relativity in the context of black holes, then we start getting weird results. And at that point, all the scientists named Singularity. But in this group of scientists, there was one physicist who did not agree with the concept of singularity. He saw a major flaw in this concept. According to him, this concept of singularity, on the basis of the assumption that all black holes are stationary, that assumption is completely wrong. Because how does a black hole form? When a massive star bursts, right? And there is a very basic law of physics, the law of conservation of momentum, according to which any rotating body will keep rotating until no external force is applied to it, or no object collides with it. Now, according to this law, the black hole should also rotate, and this is the reason why Roy had a doubt in his mind. Before reaching its root, he realized that singularity should not exist at all. Look, we have been told that singularity is formed when the black hole is stationary and only its event horizon rotates, because of which things fall like this. Here you can see that all the things going to the event horizon of the black hole are falling at the same point, and that's why the pressure of gravity at that point becomes infinite, and exactly because of which it is called singularity by scientists. Now everything is clear up to this point that how singularity is formed in a still black hole. But as we know that black holes are not stationary, they rotate. Because of which point, singularity cannot exist in it. Because if a black hole is rotating, then things that cross the event horizon due to its rotation will move around it in a circle towards the center. That is, in the depths of the black hole, the motion of these things will be like the bikes rotating in the well of death. Just like the bikes fall down due to the fast rotation in the well of death, similarly, due to the fast rotation here, things will not fall directly at any point inside the black hole, but will keep rotating in a circle motion till eternity. This means that the whole mass will not be at any center point but will be concentrated on the motion of a ring. In short, it means that singularity does not exist in the form of a point, but in the form of a ring motion. And with this argument, Kerr simply proved Einstein's theory wrong on the basis of this simple fact. Now, the thing to think here is that after Kerr's explanation, all the discoveries we have made using Einstein's general relativity, will all their calculations prove useless? Well, obviously not. Because we all know that our GPS system, due to gravitational potential differences, depends on the famous time dilation principle of general theory of relativity. Our GPS satellites travel about 20,000 kilometers above the surface of the Earth, and because they are so far away, the effect of gravity on them is less than the surface of the Earth. Now, in this case, the clocks in those GPS satellites always run faster than the clocks on the Earth. And in its solution, the speed of the clocks of all GPS satellites is reduced by using the calculations of relativity so that they match the exact time of the Earth. And if this is not done, then we will be on the road in the evening and we will get the data of the morning traffic. But this does not happen. Most of the time it is literally accurate till the last minute. This means that our current understanding of general theory of relativity still has a lot of weight. Only Einstein's theory, which was not able to predict like what is inside the singularity and what was before the Big Bang, that theory was stuck here. So maybe the concept of this new ring singularity is just an addition in the original general theory of relativity. It is an upgradation. That till now, we were using Newton's gravity for rocket launching. Then to see objects away from gravitational lensing, we have come to Einstein's GTR. Scene 3. Roy Kerr's theory. Until now, to understand the things inside the black hole, the theory that was missing instead of that, maybe Roy Kerr has taken this theory. Now what is left to understand about gravity is only quantum gravity and its true nature. Well, we don't know what's inside singularity. After all, the particles present there start showing quantum effects. There will be such small particles inside a singularity. In such a case, to understand singularity completely, it is necessary to have such a theory, which can understand the effects of gravity at the quantum level. But till now, this has been one of the most fundamental problems of the scientific community, which is to be able to combine quantum mechanics and gravity, these two fundamental theories. Now, why was quantum mechanics not able to explain gravity? There are many reasons for this, and I have already discussed them in great detail in this video, which you should not miss at all. You will get a very in-depth perspective that what is going on in the science community. And that's it for today's video, friends. If you learned anything new from this video, do drop a like. Subscribe to the Get Self-Right Science channel and press the bell notification so that you don't miss any of our upcoming video updates. See you next time. Till then, as always, stay curious and keep learning.